Alright, good day once again. Welcome to Henry's Impact International Academy. And today we're going to be treating unit vectors. So let's dive right in. Now, when we hear the word unit vector now, from the word unit, so this is a vector whose magnitude is equal to 1. So a unit vector is a vector whose magnitude is equal to 1. Are we there now? So when you get the magnitude of that vector, you get unity as the magnitude. Good. So one thing there is that the unit vector basically shows the direction of the vector components. So when we say it shows the direction of the vector component, it does that utilizing the I, J, K form with hats on them. Either now. So that's how we represent, such that the I is the unit vector to the x direction, the j is the unit vector to the y direction, and the k is the unit vector to the what? To the z direction. So quickly, what is x direction? Your x direction is the horizontal, right? Your y direction is the vertical, but your z direction is the into the page, out of the page. So just imagine you have a vector that is like this, you get, so this is like out of the page. If you enter into the board, into the page, that's the z. Good. Now, many people do not understand the concept of unit vector as a case study. Let me show you something now, so that we can understand the definition. When you say unit vector is that vector whose magnitude is equal to 1. Now, imagine you have, let's take for instance, you have now, let's say you have a vector A that is given to you as 3i plus 4g. Just imagine you have this vector. Now, to express or obtain the unit vector of this vector, it means you want to get this A in this format. And there's a way to get it. So A in this format is usually defined as the vector A divided by the modulus of vector A. That is how to obtain the definitive form of the unit vector when you say the magnitude equals 1. So you have to literally divide the vector by its magnitude. And when we say magnitude of a vector, the magnitude of a vector is simply like the result of the vector that we said earlier. So let me just put that here now. So the magnitude of the vector A, given that vector A is equal to xi plus yj plus zk, right? So if you want to get the magnitude, that's A like this, that will be equal to the square root of x squared plus y squared plus z squared. Good. Now, come back here now. Imagine this was the case you wanted to deal with. I wanted to obtain the unit vector. I get what I'm saying. I want to get the unit vector of this vector. This is not a unit vector form here. It can only be a unit vector if you see that the magnitudes are equal to 1. But if you get the magnitude of this vector here now, you're going to get 5, right? So let's calculate. Magnitude of this vector should be equal to what now? That will be equal to the square root of, following this expression here, you'll be having 3 squared plus what? 4 squared. And that should be giving us square root of 9 plus 16, which is square root of 25. So our modulus of vector A should be equal to 5. Quickly, to obtain the unit vector now, what do we now do to prove the definition of that unit vector? We will carry the vector here. That is 3i plus 4j. And we will divide it by what? We will divide it by the modulus 5. Dividing it by the modulus 5 gives us what? It gives us what? We'll be having 3 over 5i plus 4 over 5g. Quickly observe something. This gives you what? This one here will give you 0.6i plus this one here will give you 0.8g. if you check the modulus of this unit vector, you find that you try to obtain the magnitude of this unit vector. You find out that the value will give you 1. Let's do that here. So let me use the red marker to check that. So let's quickly run a check. So let's just run a check on that. So if you check the modulus of this unit vector here, we're having 0.6. 0.6 will give us about 0.36. That's when we do 0.6 squared. Let me just write it there. 0.6 squared plus 0.8 squared. And that will give us what? 0.36 plus 0.64. Upon addition, I'm going to be having square root of 1. I will know that the square root of 1 is equals to 1. Yes. So that proves that what? That this here is a unit vector, because we can see that it gives us magnitude or modulus that is equal to 1. So when you get magnitude can also be called what? Modulus, especially when we're dealing with unit vector. Alright, good. The next thing we want to quickly know is how these unit vectors operate. The I vector is the vector in the x direction. So I can operate with I arithmetically. What do I mean? An I vector or a vector in the x direction can add or subtract with or from a vector in it and another vector in the x direction. Same thing with y and same thing with z. So that brings us to addition and subtractions of unit vector. So addition and the subtraction of unit vectors. Alright, good. So the rule is very simple. I operates with I, J operates with J, and K operates with K. You have to put the hats on them. Very, very important. Alright, good. So let's imagine, given that we have a vector A, another vector B, and a vector C, so that your vector A is 2i plus 3k, and your vector B is 3i minus 2j plus 4k. And then you have a vector C that is 7i plus 3j plus 2k. Just imagine we have these three vectors, and we're told to find vector A plus vector B. We're told to find vector A minus vector C. And the last one, let's imagine we're told to find vector A minus vector B minus vector C. Yeah. So what do we now have there? On these notes, we are going to be having what now? We're going to be saying vector A, that's for part A, first part, vector A plus vector B. That will be what? What is our vector A? Bring it out here. 2i plus 3k. Then we have it here in brackets, that's standing for vector A. So we now have plus vector B now, which is which one? This is vector B. We have your 3i minus 2j plus 4k. Alright. So how do we solve in normal math? We can open the bracket, this plus 1, can use to open bracket. So since it's addition, it does not affect the sign. So we just have this repeated, that's 2i plus 3k plus 3i minus 2j plus 4k. So let's quickly follow what we wrote here. 2i plus 3k is impossible. We said that I operates with I. So let's quickly take all the i's together. So I'm having 2i plus 3i. So I'm having 2i plus 3i. Then we now have minus 2j. Is there any other j? No. So we go to k, plus 3k plus 4k. So quickly, what do you have here? 2i plus 3i gives us 5i. Then we have minus 2j. Then we now have plus 7k. And that gives you the answer to this first part. It's very, very simple. quickly let's apply this same knowledge now and answer this A minus C. So for that one there now, vector A minus vector C. What's our vector A again? 2i plus 3k. So we're having 2i plus 3k minus, then C is what? 7i plus 3k. 7i plus 3k. I think there is a plus again, then plus 2k. Okay, plus 3j rather, then plus 2k. So what do you do? Normal mathematics, this minus sign is going to affect every sign here. So we are going to be having 2i plus 3k, right? Then this side here now, minus, open everything here, this will be minus 7i. Then we are, instead of minus now, minus is plus minus, that's minus 3j minus 2k. As usual, we're having 2i, I operates with I, minus 7i. It's only minus 3j we have here, and we have plus 3k minus 2k. 2i minus 7i gives us minus 5i, and we're having minus 3j, then we now have plus k. That will be the solution to that. Now, this last one, I want you guys to try out on your own and drop your solution on the comment section, or you drop your solution with any of the admins on our WhatsApp channel so that we can quickly go through it. We'll still revise that. Alright, good. Now we move into the next thing. We looked at addition and subtraction of unit vector. Now we're going to look at multiplications of vector. Multiplication of vector. So this multiplication of vector is going to bring us into two kind of multiplications that we'll be dealing with. We are going to be dealing with your dot multiplication and your cross multiplication, or what we can call dot product and cross product. So we are having that here. We have the dot product and cross product. So imagine we had vector A and B, and I want to express them in terms of dot product. This is how you write it. You say vector A dot B. That's a dot product. But if I want to write in terms of cross product, I'm going to be writing vector A cross B. They are not the same thing. So in our vector multiplication, like multiplication of vector, we have them in terms of dot product, and we have it in terms of what? Cross product. Very, very good. It's very easy. Now your dot product is simply the product of your what? Of the modulus of the two vectors cos theta. But your cross product is, look at what I'm doing here, your cross product is the modulus of those vectors sine theta. This thing is not complex at all. It's very, very, very simple. So when you're dealing with your dot product, this is what you have. When you're dealing with your cross product, this is what you have. Now, in terms of operation, there's a way you operate with your dot and cross product. Let's imagine we're doing A dot B. Which is from this same question now. So A dot B. The rule here is that you need to understand that I dot I, which gives you I square, are we there now? Which gives you I square is equal to 0. Same thing with J dot J, which gives you J square is equal to 0, and then you have K dot K, which gives you K square equals to 0. Yeah. So quickly, imagine we were solving a question like this here. Where is that? Imagine we're solving a question here, and we're having A dot B The A is which one here? The A is 2I plus 3K. And then you're having B, which gives you what? 3I minus 2J plus 4K. Good. So if you're operating with, sorry, we have made a mistake there. We mean whenever they are multiplying things that are non-identical, then to give you 0. So if you are multiplying this now, what you'll be having here is what? If I want to do the normal multiplication, you'll be having 2I times this, right? Then you now do 2I times 2J. By the time you do this 2I times 2J, you'll be getting minus 4IJ. So you don't need to write that out because that minus 4IJ will give you 0. Because IJ, we said, will be 0. Sorry, that means there will be no need of all these parts. We just have 0 there. So anytime you multiply any of the non-identicals is 0. But when you are multiplying the identicals, you get unity for them, for 1. So good. If I do 2I now times 3I, what do we get? We are going to be getting 6I squared. That's as good as me just writing 6, because I said that your I times I, which is I squared, should be equal to what? 1. So in terms of later times, I will no longer have to write this I squared there. I will just write the answer direct. And good, another thing we don't need to do, we don't start opening it one by one, because we know that I with J will give you 0. So the way you multiply in dot products is just to multiply identicals. The i's will multiply the i's. So that what I'm trying to say is this. Our I parameter will multiply the I parameter. Then your J will multiply the J, of which there's no J in this particular vector. So that automatically gives you 0. And then your K will multiply with your K. So what do we have here? I'm having 6I with 2 times 3, that's 6, I times I squared. Then we don't have anything to multiply with this J, so it's as good as 0J is what is here. So 0J multiply with this to give us 0. So I'm just going to write minus 0J squared. You get what I'm saying? So when you see a vector like this, when you see a vector like 2I plus 3K, it means that that vector is 2I plus 0J plus 3K. This thing can lead to people getting questions wrong. So you should always remember that whenever they write this, the J is there, just like it's 0 in terms of its parameter or value. Now, in this place here, plus 3 times 4 gives you 12. So we're having plus 12. K times K squared. Based on this rule, identicals are 1. So it means that this 6 times 1, 6. So I'm having 6 minus 0 plus 12. Because all these squares are 1. So automatically our answer is what? 18. So in terms of dot product, when I did the dot product of A and B, that is this A and B, the answer is what? 18. Very, very, very simple. Very, very simple. Let's try again with another one. It's not dot product I'm doing, it's not cross product I'm doing. Another dot product example. Let's imagine we're doing the dot product of B and C. So the dot product of B and C. If we want to do the dot product of B and C, that would have been what? So I'll be having B was 3I minus 2J plus 4K. While your C was what? 7I plus 3J plus 3J plus 2K plus 2K. So as usual now, we are going to be multiplying I with I, J with J, and K with K. Why? Because we've known that the multiplication of two non-identical unit vectors will be giving you what? 0. So we don't need to start multiplying like the normal mathematics. We multiply identically. So here now 3 times 7, 21. So I'm having 21. I'm not going to write I squared because I know that that 21 I square, that I square gives you 1. So there's no need of writing that. Minus 2 times plus 3 gives us what? Minus 6. And then 4 times 2 gives you what? 8. So here what do we have? 21 minus 6. That 21 minus 6 there will be giving us how many? That will be giving us 15. And then we'll now have 15 plus 8 to give us 23. If we're not mistaken. 22 or 23. So here we have 23 as our answer So that's the vector dot product there. Now it's very important for us to understand, before I start doing the cross product, it's important for you to know that this theta and this theta here represents the angle between the two vectors. This is very, very, very key. It's very, very key. You just need to keep that in mind. Keep that in mind, because we're going to be working with that very, very soon. So now we are going to be going into cross products.